Hello, my name is Jacob Magnon, and today we're going to be looking at Lab 3 for Physics 2211, which is based around a black hole. Let's get straight into it. So we're going to start by looking at some fundamental principles and equations that we need to know, and then move on to the purpose of this lab. This lab is split into two main parts, the first being finding the mass of a black hole, and then the second part will be finding the trajectory of a ship that is traveling around that black hole. Finally, we'll do some analysis and answer some questions at the end. Looking at our fundamental principles, the momentum principle is going to be very important today, and I've rewritten it so that our net force is equal to the change in momentum over the change in time. Then below that, I've written down the gravitational force equation, and it's going to be important to note that for circular motion, the net force is equal to the sum of the forces in the perpendicular direction plus the sum of the forces in the parallel direction. So in the first part of this lab, the purpose is to find the mass of a black hole, and we're going to need to use the momentum principle and the forces that are associated with circular motion. The second part, we're going to launch a ship off of a planet that orbits a black hole, and so we want to get close to the black hole, but we also don't want to crash into either the planet or the black hole. Finally, we want to demonstrate our knowledge of the relationship between force, momentum, and circular motion. So to find the mass of our black hole, I first set our net force equal to delta P over delta T, and then split that up into its perpendicular and parallel components. Now, if we want to find our perpendicular dP over dt, we can set that up as shown in this green equation, and then substitute the dP dt in the parallel direction for this shown here at the bottom. So once we do that, which I have shown here in the top right, all of this we can solve for in our code. So we can substitute our net force in the perpendicular direction as being equal to this, and then set that equal to our gravitational equation, and then solve for the mass of the black hole shown here. So for the coding in this part of the lab, start out by finding our net force, which we do by finding dP dt, and this is all shown right here. And then we'll move on to finding the individual components of the force. And we do that by finding dP dt in the parallel direction shown here, subtracting that from the overall force to get the net force in the perpendicular direction. Then to find the mass of the black hole, we simply use our equation that we found in the last part and plug in all of our variables, and that will give us our mass. And over here are shown some of the other lines of code and the net forces that we found. Alright, so this is what our star looks like as it orbits around the black hole. So moving on to the next part of our lab, we first want to calculate our net force for our planet, which is shown here, where the system is our planet and the surroundings are the black hole and the ship. And then over here on the right, we see our system is the ship, while the surroundings are the black hole and the planet. And all of these forces are just going to be gravitational. And then down here at the bottom, we see our velocity and position update equations, which we are going to use later. So looking at our code for the second part of this lab, we need to find the net force on the planet and the ship. And for the planet, that's going to be the gravitational force of the black hole plus the gravitational force of the ship on the planet, which is simply going to be our gravitational force equation times r hat for each one. And then sum these up to get our net force for the planet. And we're going to do something similar for the net force on the ship. And then for our velocity and position update, we're just going to use those equations that were shown on the last slide. And our initial speed for our ship was just found through trial and error. But after we put this into the code, this is what our picture looks like. Alright, so now you might want to ask, what's the difference between the components of net force and our change of momentum over time? Because in our equations, we pretty much just set these equal to each other, but of course they are not the same thing exactly. Net force is a measurement combining mass and velocity, while the change of momentum over time relates mass, velocity, and time. And then what if we wanted to orbit the black hole instead of just get close to it? So to obtain orbit, we need to reach this speed, which can be found by setting the parallel and perpendicular components of force equal to each other. And then if we do this, we're going to get that our velocity in the x and y directions looks like this. But that's about it for this lab. Thanks.